Okay, looks like we are live, so welcome back. Today I'm going to be continuing to work on Kano script. Okay, so a couple things before we get started. I did make a couple of changes to the scripting language, right? To Kano script. Yeah, so now we can support this, right? So we can have parentheses. That was not something we could do before. So that's cool. So like this will actually evaluate properly. I don't remember exactly what it is, but it's yeah, 37. Okay, pretty sure that's right. I did check it before, so it does work. Yeah, so that's pretty cool. And then also I updated some of the examples. It's like printing here. Yeah. Okay, so that's actually the same. But the stir compare and stir len. Now we put print in there. I just copy and pasted it for now. In the future, I'm going to like implement a way to import files, right? Probably using the preprocessor that I made. Yeah. So we can do that, and then that way we won't have to import each time. But for now, we have to do that. Yeah, and then we can just string compare, and it will actually output the correct result. So if I go into the build, and I can modify the run sh to use string compare. And then if I run it, prints out 1, right? And if I modify it, so I'll make this not the same, right? Then run it, it will print out 0. Because that's true and false right now. I'll probably implement something on the level of the compiler to be true or false, so that we don't actually have to work with 1 or 0. But for now, that's what we've got, like actual built-in types, right? Yes, that works, and we can look at the Sterling as well, because that's a bit more interesting. The string is x characters long. I think it's 27, if I'm not mistaken. Sterling, so we can run that as well. And there we go, 27. Yeah, so that's pretty much it. And it's pretty good now. So, got some good stuff. And yeah, so I think, yeah, today I'm going to work on a few more types. So I want to implement floats and characters, right? Characters really are just integers, essentially, but it's nice to have that. And then we can make an array of characters, and that's basically the same as a string, right? So that's sort of the idea right now. Yeah, we have support for that on the level of the virtual machine, so it's just in the compiler itself. So let's get started in the front end. Okay, so first of all, actually we need the token type, right? So we have token type integer. Let's add token type float. We already have chars, right? We can lex and parse them, so we just need, well actually we need to update the parsing in certain places, but yeah, we'll get to that. But then float, and it's really float literal, and I should change this to int literal as well. So let me do int lit. I think that is clear enough, right? But I'll start with float lit as well, so that I'm not change it later. So then parse, so it really is in the lexing. So here is alpha, so that's not what we want. We want is digit there. So in here, so we're gonna iterate over this. Was there and or view.data equals a dot, right? Because if it's a dot, then it's a floating point number. So then, if we have a dot, if view.data equals dot, then token.type equals token type float literal. Otherwise, we'll set it actually up here. Yeah, token.type equals that, and we'll just set it to this otherwise. And at the end, so that will just iterate through and collect it all into the thing. So here we have to do token.value.integer is that if it's an integer, but if it is a token.type equals token type float literal, then token.value.float equals a top. I think that's what we're going to use, num.data, right? Else, let's do this. Yeah, and then that will be the device. We do need to add that to the token as a, it can't be called float. Loading. I guess that's what I call it. I don't know. It's not. I don't really like either of them. That means we have to modify in here. So in the token type, not token type, but token value, we need int integer. We have double. I think that's what it is that we use in the virtual machine. So this is a float, right? That's what we use. I'm just thinking. So I think that is pretty much it for the lexing now. So we have to add it to parse expression, or parse primary, right? Parse primary. We need to add support for token type floating. So let's just let's grab some of this right here, and there we go. So if it is float literal, then we'll create this, and token value, yes, this is the expert, so we need to update the expression as well. Floating, I'll call it the same thing, token value dot float. Okay, and the location is going to be the same, and everything else there is going to be the same. So we do have to add it here, so I'll probably make a function for this, but for now I'll just do if token type is not equal token type float literal. Yeah, so that needs a bit of update, a bit of cleaning, right? Let's update the expression now. So I think it's in here. Expert value. Do we have that? Yes. Okay. So we need double floating. We need expert float. Float. Okay. That's what I set it to. I just want to make sure. Parse primary. No. So I need to update this. Expert float. Okay. And that's pretty much it for the parsing and lexing, if I'm not mistaken. So I just do want to try it out really quick. So I'll go to the main.c, and I'm going to print the token array, and then return 0 here. I'm going to try it out. So let's build it. And nested functions. Do I have a nested function, really? Okay, I messed something up. I think I forgot a closing bracket somewhere. Probably in the parse primary. Probably mess it up in here. So let's see. We have this. That's valid. Yeah, I see what it is. So let's, yeah, there we go. And that caused a lot of problems. So let's build that now. And then we have a few things. So around that. So, oh yeah. In these digits, or yeah, so this needs like parentheses, right? Yeah, okay. Like that. There we go. Okay, what else? That's the same thing, but we'll come back to that. Expected that or that. Oh yeah, I put double and here for some reason. Yeah, I don't know why I did that. Okay. Now we have, that is not here on the switch, that's okay. 5, 6, 7, that should be easy to do. So let's go to token type int. Right here, and then we'll just add base token type float. And that should be float literal, right? Okay. And there we go. So it does compile. I want to see what it outputs. So let's open Kano, and let's just do xfloat. And actually, I realize we don't have support for that now, do we? Yeah, we need to add it as a type. Equals 6.5, right? So right now it's not going to be. Yeah, so it sees as an identifier. It does lex it properly though. So we have wait, maybe it doesn't. Type. Huh. Did not does not seem to have worked. Let's try exit with 5.2. What does that say? No. Exit, and why does it say type? Token array. Do we have that still? Oh yeah, because I did not add it to the token types. Oh, I forgot about that. So after integer, we need to add. Is that the right order? Char, string, integer, float. No. So we need to swap string and char. Everything else is fine. Okay, so we'll just swap that around like that. And char. Okay, and then let's see. And void. Okay, so it still sees it as a void. Why is it the wrong order? Let me see. Let's see. I just want to make sure it's not because of the comment. I don't think it would be. I don't think why it would see that, but just to make sure. Yeah, that's not what it is. Okay, I thought, but okay. So you have string, char, int, float. I must be missing one. Missing one from here. Let me copy it all over, and then I can compare more directly, right? All right, so we have none, right? Exit. Hang on, let me zoom out a little. Exit ident, colon, open paren, close paren, open bracket, close bracket, comma, equal, double equal, not equal, greater equal, less than equal, greater, less, plus minus, multiply, divide, mod. Okay, I implemented mod, I forgot about that, and then I forgot to add it here. Okay, that's what the issue is then. Okay. easy enough, because it's just for like debug purposes. So it's not like strictly necessary. Also, I think for printing, that is where it was at. Okay, exit and float, perfect. That is exactly what I want. So we can do that. Exit 5.2. Okay, yeah, and I want to actually add the type. So let me just do that, right? So x float equals 12.9. Okay. So that should say, yeah, float. Okay, so instead of an identifier, we need it to be the type. So, actually, how do I do the types here? Yeah, okay, so we have the list of these. So, we need to add a type. Alright. I think it's in the defs, actually. Yeah. Type. So we'll just add type float. Okay, and then how was that handled again? Let's go back here. Type. Yeah, so data types I. So I need to add that to there, which, where is that? Is that fine up here? Yeah, it's right here. Okay, so I need to add this and the length of the word. So float. Really, it's a double, but you know. Okay, build that, and then, yeah, so that should be all that we need for that. And now it can parse that as a type, which is exactly what I wanted. So that should be good, actually. That should be good. So that should be it for what we need to do there. So we should be able to parse it. I just want to make sure that works, and then we'll get to the generating. And yeah, it's no save vault, so I'm assuming it works. So let's go to always a good thing to just assume it works. Okay, we will. I need to add, yes, we need the data type size. It's gonna be 8. So I probably change the word of it. But it is 8. It's 64-bit. So okay, yeah, I can that. And let's see, I don't think I need anything there, so it's really just in the gen exit. We just need to add the case of a float. And I'm not gonna do any advanced type checking right now. Float. Dot float. Floating. Okay. Yeah. Alright, let's go here. Actually modify this to do Kano and try to run it as well. And we got 0. So I don't know if we can exit with floating point. Oh shoot, we don't even exit with it. We don't really have a way to print, I suppose. But yeah, it just prints out 12. So I can look in the assembly now and make sure it is pushing it properly. Pushes 12. Okay, that is not correct. Okay. Why does it do that? Wait, what? I seem to have messed something up. Let's try to print it out. Extra value dot floating. Let's see, do we get to this point? We do, okay. Oh shoot, because gen push float. That is what the issue is. Wait, why did I not get a warning for that? Because we're passing that. Even though it's expecting an integer, you know? Gen push, and then we'll have gen push float. Float, okay. Double. Okay, and that should work. Yeah, so we still can't exit that because that's not how it works. But if we look at the assembly, we should see 12.90, and if we try to print that, then we can take a look at it and make sure it's all good. And yeah, 12.9. So that is correct. So we are good. So that works. We don't really have a way to interact with it yet. We can implement like print float because we have print int right now. Yeah, so we'll get to that. That's not super important right now. And let's see. So we don't really have the character as a type, so we should add that. So I'm just gonna work backwards. Okay, so 1. We need 1 there. And then we can go to. Hey, Alavaz, how you doing? How you doing? What is up? It's the right one. Swag type char. So we need that for sure. And here, Put it here. Char. 4,000. Nice, nice, nice. Let's see. Yeah, might not make it. Might not make it. I might just do it anyway though. Because I think it could be fun. Char. All right, land full. We already have char, so we're good with that. So we should be able. That should be actually all that we need to do to support characters at 8 type. So if we open up this now, should be able to do char. Hello, how you doing? Sure, run it. And yeah, so it does that. Let's do uppercase A. Yeah, okay, so that actually works. Oh yeah, Gleam, I heard about that. I heard about that indeed. Yeah, it does look interesting from what I've seen. I haven't looked into it too much, but it might be interesting. Yeah, it looks like that kind of looks like Rust, but looks kind of like Go as well. Doing good, glad to hear it. I am good as well. Today I'm implementing more types into the yeah, Go Rust Elixir. Unlimited Elixir. Adding more types to the language. Yeah, so basically characters and floats. That's sort of the goal for today. Right. So, yeah, because before we only supported integers and then strings, which are essentially just arrays of characters, you know, like, imagine this, you know, like how it is in C, right? It's like that, but we didn't support characters themselves, so this sort of makes it better. So like, we could declare a string like this, so that's the name, and we have stir, so maybe I won't call it, I'll just call it n stir equals, we could do this, but we couldn't define a single character like this, but we can do that now. Yeah, so that's basically what I'm working on now, as well as floats. No speed, yes indeed, I will do that. I'm going to try to implement it in the language itself as well, so that should be fun. Should be fun. I think we should support this as well now. There's not really type checking right now, though. So, like, you can put incorrect types, and it's going to compile. It won't work properly, but I'm going to get to type checking a bit down the line. Yeah, so it looks like that worked as well. And it did push that. This, yeah, it's going to, tries to print the pointer to it. So that's not great. But we could try to exit with, I don't think it's going to exit the right thing, so that's actually not going to work. Stack was corrupted, really? Why is that? What? That is interesting. Very centered, so you build an LSP for Kano. Hang on. You need to build a client-side server. I don't quite understand what you mean. You mean if you build one for Kano, then it won't work on Neovim? Is that what you mean? Okay, yeah, I'll need to look into why that happened. Let's try this. H E. Okay, sure. Let's try that and exit with kind of right. And that should break the string. And yep, there's no null termination. So if you add a null termination, it's the same as a string. Yeah. Alright, so that's cool. You have the client, the editor. You have to build. And the server, that is the LSP that runs. Yeah. Right. Okay. Yeah, well, so the client would be written in Kano script and then integrated into Kano. Yes. Okay. So let me think now. Why was I trying to do this? Yeah, X. Yeah, why does that happen? I need to look at that. So, back in. Racket Squash followed. Thank you. Appreciate that. So 122, right? I'm trying to exit with that. Bar index. Why does it have to be greater than 1? Want to build a language? I know how to build Lexer, but not an AST and a parser. Okay. Yeah, well, let's see. Something that helped me a lot, specifically with parsing, like, expressions, which is the most confusing part for me. I said it. Yeah, something like this. So, I can put the link there. Like, just the Wikipedia page, just reading through it, and you can look at the pseudocode. Yeah, and it's pretty easy to translate this into whatever language, like probably Go in your case, since I know that you are quite familiar with that. Yeah, so like it doesn't show the parse primary function because that's sort of you have to implement it yourself. But you can also take a look at like there's a bunch of other ones, but mine specifically, I have some stuff in here. So like if you go to this GitHub and then go to the Kano script, I have in here defs.h, right? And I have sort of the structure of expressions that I have, and also different operators, some types, expressions that like binary expressions, things like that, and that might be helpful as well. Yeah, and it's pretty concise. Like a lot of this isn't really relevant to it, but the things I say like expr and operator, things like that, are relevant. But yeah, that is kind of the hardest part to kind of wrap your head around. Also, there was a good YouTube video. Let me see. I'm gonna see if I can find it. Let's see. Give me a sec. It was a helpful video. Yeah, right here. Hang on, it's loading. Let's see. Yeah. Parsing is much simpler than you think. This one, I can share the link to that as well. Right there. Also want to build a Trello-like app. Oh, nice. That'd be cool. That would be cool. And not too far. But yeah, this was a good video. Like, it sort of explained things well, I think. Helpful for me, at least. Okay. Where are we at? Yeah, so I was trying to... Let me figure this out. So, where was I at? In here, 1.2, I think. Yeah, so of course with HTML. Yes, no doubt. Yeah, that could be cool. That's like a cool project that would actually be useful. So why does this have to be graded? I don't get that part necessarily. It doesn't break if it is not. Is that? That's probably what this is. Actually, it was not this one. It's this. I want to make sure because that's 65. So yes, that works. So why did I have that? Because there was obviously a reason I added that. I don't remember why. So we're going to print at the stack size, right? Stack size. So I'm going to see what that is at this point. And it's 1. Okay. So yeah, that's just on the... So I don't know what this is for. Let's see. Why this was here. I don't think it breaks anything. So I'm going to, test some of these things that I have and see if they work. So like this works, obviously. Get rid of that print statement though, because that's hard to get rid of it. See if they rebuild. Doing Trello app first. Okay, nice. I would definitely like to take a look at that once it is complete. Land, yes, we'll try that one. Not big. So I'm trying to make sure that this one still works. And it does. Okay, so I don't know necessarily what that's for. Yeah. I might have to rewatch the VOD and see what I was thinking when I put that in. Yes, but this should work now. So I will commit that actually. Implement support for float and char types. Okay. Yeah, so that is cool. That is cool. Okay. So yeah, we have that now. And the thing is, you can use it in expressions, right? So if I go to build, modify this. So let's say we have something like this equals 12 plus 5.0 or 5.5, right? So what is this gonna? If I try to exit that, what's it gonna do? Because it's an integer. This is an integer. There's no type checking right now. Let's see what happens. That's not what I want to run. Let's do hey now. Okay, now let's try that again. And we get 12. Okay. Whoops. So yeah, 12 plus 5. So that's not great. Let me look at the ascent. So push that and it adds it. And then what is it? interprets it as a float, if I'm not mistaken. I think the what is on the top of the stack it interprets it as. So if I print that out, it looks like it's going to be a float, probably. Oops, nice. Messed that up. Let me try that again. Add an string. And I have to compile up this. Oh yeah, and it interprets it as a float. Why is it 5.5 as the float? Let's see. I'm not exactly sure how to pronounce your name. So I'm just going to say Mao. Followed. Thank you. I do apologize for that, by the way. Yeah. So I don't quite know about this. Like, if I switch it, what's gonna happen? It does that. Actually, it doesn't print it out. But I think I got rid of that. We have the print same thing. I just want to see what this like gets interpreted as. As for why is it always just the 5.5? You know, then the stack is there. So that is not great. Yeah. So let's see. What can I do about that? Like obviously, when I actually like I'm gonna implement casting, right? So you can cast two different types. And then I'm going to have type checking so that if you have incorrect types, you have to cast them before. So like if you want to do this, you would do something like I'd look like this, you know. Cast maybe like I'm not exactly sure the syntax, but something like to in or whatever, you know, something like that. So it'd be like a native function that you would call. Not really a function, but it will call that, and then it will cast it, right? So we do have support for casting. So I can actually, I think it's like foot to in, like that, and that should cast it, and then this should be valid, if I remember it properly. So it did work, and there we go. Yeah, so that is how it's gonna work, sort of. Yeah, and it'll be built in like that, and then we can cast to all the different types. You know, U8, U16, all that stuff. Float, char, everything like that. But for now, like I don't really want implicit casting, right? I want it to be very like you have to be very specific about what you want exactly, you know. Because of things like that, like it doesn't really work. Like I could just interpret it as an integer implicitly, right? But that's not really ideal. Try to pronounce this N. N. I don't know. I apologize. I am not. I am uncultured. I also don't think this will work. It's not an N. Well, it looks like an N to me. And I don't know how it would be pronounced any other way. So what does this do? Oh, shoot. We have to use add if it's a float. I forgot about that. Yeah. Okay, that is a thing. Put it on a Spanish voice in Google Translate. Okay. Copy this. Twitch is popping stuff up. Trying to copy, but it won't. Whoops, I didn't mean to pin that. Okay, having some problems. Oh, I got it. Gotta change it to. Okay, I don't have sound on.
Ñ.
Is that right?
Ñ.
Enye?
Ñ.
Is that correct? Enye? Like, obviously it's not, you know. I think you could hear that. I think the sound is probably. Yes, okay. Yeah, I'm sorry. I'm not very familiar with Spanish. And it prints it out like that. Yeah, because it puts it as an integer. And so we need to use add, right? So that's something else. We'll have to check what the type is. Yeah, so each expression, it's going to have a single type, right? For the total expression. So I'll need to consider that as well. And then we're going to generate one of these based on that. So addif, modif, things like that, right? Because it's not a known sound in English, so the joke is trying to make English people pronounce. Yeah, I see. I imagine most people just pronounce it like an N, right? Most, English-speaking people. That's not right. Wait, what? Oh shoot, did I actually? I think I actually did this. Get that. I don't like that. I don't know why I would do that, but I think that's what I did, isn't it? Yeah, that is indeed. Okay, but now this will actually work. 17.5. Yeah, so I'm not going to support that yet. So you can't actually do arithmetic with that, because that's going to be a bit more complicated, the types that we'll have to do. Yeah, I don't want to do too much type checking yet. Okay. Right. Yeah, so this isn't really supported at the moment. You can just set it to a single one or an array. And that's not like super important. Like you use floating point arithmetic that often, unless you're doing like game dev or machine learning stuff. Text describe the sound to a person that doesn't speak Spanish because it's a unique sound, right? Yeah, I understand. I get it. Something good. This will work. Plus A, right? Actually, that might be too large, but that would work. 162. That might be what it is actually. Because it's basically just integers, right? So again, I'm gonna add type checking for that as well, so you can't just do something like that. You know, maybe you can't even use plus at all on a character, because I don't know necessarily that I want that. But you can use something like this, you know, plus, at least right now, plus 0, and then 53, which is 5, right? Is that right? And 0 equals x, and then, I want to see, so I'm pretty sure. Yeah, 5. Okay, yeah, so if you add 0 to it, then it will do that. Or 48, it could also be 48. And it's the same thing, because 0 is 48. Yeah, okay, cool stuff. Alright. So, what do I need to do? Okay, not quite sure. That's kind of all that I had planned for the moment. I guess, so, probably not going to work on it today, but I'd like to implement a few more ways to, like, allocate, right? So, right now, we can allocate arrays, right? We can do x int 3 equals 1, 2, 3, something like that, right? Yeah, and that will allocate an array, 3 characters, and that is the data that we'll just write into it. And then you can, you know, index it and all that stuff, and change it, and stuff like that. That's all cool. But there's not really another way to allocate blocks of memory, and that'd be nice to have, right? Love JetBrains software, except for Android Studio. Well, Android Studio is like a fork, right? Or like a partnership. Yeah, I mean, it's pretty good. For an IDE at least. Not a big fan of those. Yeah, so I'm thinking something like this, right? Alloc, and then the amount of bytes. So like 8, for example. If you wanted to store an integer, something like that. And then this would be an expression. So you could do something like that. Yes, but it's very bad. Yes, I am familiar. So then you would return a pointer here. Equals that. Really, it would be an int pointer, right? So probably just a PTR. So add the PTR type. And for now, like I may change it. May change it to not be a void pointer. Boolean is amazing. I've not used it, so I don't know. But I do believe you. I believe you. I could see the appeal. But yeah, so it'll be like a void pointer essentially. And this will allocate space in the memory. And then you can store, right? So we have to like store, and this will take a few arguments like pointer, and what else? Pointer and also what you want to store. So that data. So say you want to store, like it'd probably be a pointer to the data. So like say you have, yeah, say you want to store x there. So we'll allocate 8 times 3, right? That's what we want to allocate. Because we have 3 of these, right? 3 integers. So I want to store that. We want to store all of x. We want to do, 8 times 3. So like the number of elements. And that's what you would store there, right? Something like that. And then also you can read from it. Well, actually you can read from it the same way. So let's actually make this P. Yeah, there we go. And then you could do like P1. Basically, if it's a copy of the array, essentially, that's how we would do something like that. And that would also allow you to realloc. So I can implement that as a function, realloc, where we'll take take the array, you pass the capacity, the current one, and then it will allocate a new one with like double the capacity or whatever. CandleScript is not simple, not yet, right? Like, well, this like I'm gonna build functions on top of it that sort of take care of a lot of this stuff for me. This is sort of how it has to work at the lower level, and then I am planning on implementing like a fairly simple garbage collector. My screen got orange, by the way. A fairly simple garbage collector. Say like for most programs, you won't really have to think about it. Some more complex ones, you might have to think about that a little. But yeah, like at the lower level, as it gets started, it's going to be kind of complex and low level like C. But then as I implement the features, I'll build, standard library functions to take care of some things, like copying arrays, things like that. And then also going to implement some stuff as well, like safety features and stuff like that, checking. And then things like that. Versatile. Well, not yet, but hopefully it will be. Yes. Like, because I would like it to be fairly simple, probably more complex, quote unquote complex, and something like Lua. Like, it's a bit lower level than that. Yeah, that's the idea. Like, the garbage collector will be like a compiler flag, is the goal. And it's just gonna be very simple. Like, I don't know too much about it, but I don't want like a big overhead to it, really. Yeah, things like that. Also, the way that we allocate memory currently, it might be a little slow. Because it's sort of like uses malloc, but then it also has a few other things that it has to do to like keep track of it properly. So I'll probably implement a way to also just call malloc directly if you want to completely manage it on your own. Like you would get rid of any safety features that I might implement and things like that. But that way it'd be faster and more efficient. Like it uses less memory, things like that. So it's gonna be like a lot of sort of you can have as many layers of like you could let's see, I don't want to explain this. Basically, you could do things at a very low level if you wanted to, like basically like programming in C. Or you could do things at a higher level where you don't necessarily have as much control, but it's obviously simpler. When it's done, we move to Kano OS and then to Kano Computer that ships Kano OS. Interesting. Maybe. I don't know. Is a piece of software ever really done, though? That is the idea. Yeah, the thing in CanoScript, though, you might have to think about pointers once in a while, and maybe like some allocation. But other than that, it's not gonna be like quite as much as C. And Mars, of course, yes. Kano World in Mars, no doubt, no doubt. What else? Yeah, and then also there's casting. So I don't want to handle casting. Like, I don't really necessarily like the C one. Like direct like that. Maybe like cast to in. Right, if we just do that, we know the type of this. So we'd be able to interpret if it is a float or whatever. So we can just do like 2 int, to, U8, 2 int 64 if you want to do that, which is just the same thing as int, at least right now. 2 char, 2 float, 2 double, things like that. So that's how the casting will. Yeah, because it will be like strongly typed. You won't be able to mix and match types, right? Okay, so we have that. Storing pointers, allocating them, and right. So this is a native function similar to exit, right? So exit's a native function. That's why there's no braces, brackets around it. What is it called? Is it called parentheses? That's what it's called. I always get those confused. And this is a void, right? It doesn't return anything else. So you wouldn't be able to use, x equals exit 0, right? That's not valid. But it is an expression. So I need to differentiate between void expressions and expressions that return values. Like alloc would return a pointer. So we need to keep that in mind. What other native functions might there be other than alloc? Well, the malloc one, that's basically the same deal. There's also going to be dealloc, right? Which probably wouldn't return anything either. Like, it would just be dealloc b. But again, like, you shouldn't, most of the time, have to think about that once I implement some things. Yeah, okay, so that's sort of the roadmap, the goals. Okay, is there anything else in here? Yeah, I can also show, so the, I didn't show this, but I did implement parentheses, right? Support for that in the parsing. So parse expression, parse parameter. So it's actually quite simple. So all you have to do is in the parse parameters, this is where like the lowest level, like when you have the integers and the floats, things like that. Like so 5 plus, or 4 plus 3, this is a binary expression, right? And then the left-hand side of that is 4, an integer. Right-hand side is 3, an integer, and the operator is plus, right? So that's sort of how it's built. So basically what I do here is, if we encounter an open paren, then we parse it all as its own expression. And it's actually quite simple. Just try C#. I think you will like it. I had used C# before. That was actually my first language. Yeah. I mean, maybe. I don't know. I mean, I like Go. You know, I do like. Why use C# over something like Go? Like, cause Go is compiled. Like, I think C# is like Java, right, with the virtual machine. Real C with classes and garbage collector and stuff, right? Like, I don't know. I think Go is more appealing to me. .NET framework. So that's like the whole thing, right? I don't quite get how it works. It's kind of confusing name to me. But yeah, you have the .NET framework. It's not use a VM. It is not. It used to, right? It's compiled now. Mm. Replaced by switch case. Yeah. Oh, well, it just started out as 1 or 2, and then I never, changed it back. Yeah. That's why. Yeah, I thought so. It is. Yeah, I mean, I can change it to a switch case right now, I guess, if it bothers you. Switch. Okay, we have that. Let's see. Back down. I thought it was compiled. That's why it has a use case in every platform. Yeah. There probably is a way to compile it as well. Mm, don't want. Yeah, I think we did. Probably okay. We have quite a few of these. Yeah, so this one needs these because we define. Well, no, we don't have to define it, so we don't need that. You can just do that. Like we do with the rest of them. So I don't know why I did that. Just like that, actually. Server client with WASM web apps, cross-platform mobile apps. Yeah, but how does it work on Linux? Like I've heard that support with Linux is not necessarily great, right? Because it's made by Microsoft, so. Okay, we have this. This one's kind of long. Whoops, it actually only goes to here. So let me see. Wait, which one is that part? This is not. This is still part of it. Wait, maybe it's not. Hang on. Oh yeah, that's it. Okay. Yeah. So this is not part of it. So no, it is part of it. Hang on. Yeah, I just made a stupid. So that is all for the identifier types. That's all good. .NET Core is class one. Yeah, yeah, yeah. For like the development part of it, right? You're supposed to use Visual Studio and stuff. Okay, so that's the switch. Need a bit. Okay. Wait, it still works. Oh yeah. So then we have the default case, and we will just So, well, I'm not sure if there's a way you can trigger that, so I'm gonna tell it. I don't think so. You shouldn't be able to. Use JetBrains Writer. You absolutely need an IDE. JetBrains Writer. I've not heard of that. That I imagine it's JetBrains for C Sharp, right? Unexpected expert. Unexpected filter. So actually, probably can use it. Oops, that's long. Okay, there we go. Then it works, and hopefully. What? Oh yeah, because we don't have these anymore, so we can't do that. Then yeah. Whoops, that's not right. Okay. Yeah, JetBrains Writer. I didn't know that they had one for C Sharp. Is it like Java where you like need an IDE pretty much? I think there's actually what's the other one called? Mono develop, is that on that is one as well, right? Yeah, that as well. Because I remember that was integrated into Unity, right? Yeah. I might try it sometime. Okay, that should work. Okay, very nice. Okay, now it's switch statement, so hopefully it is better. What else? Don't need an IU, but it could be used for some stuff. Okay. Okay. Okay, that is okay. So architecture and switch case. I mean, that's not a weird. That's a good way to work. What is it? So it is vector to a switch case. Okay. Web servers goes way better. Okay. Yeah. Well, I mean, I did like Go. I wrote. It was just simple, but you know. Free course on YouTube about HTMX. Yeah, I think I saw that. I mean, I didn't watch it, but I did see it. And if I was into web dev, I would probably watch it. Okay, actually, this is a very old comment. I should get rid of it. Yeah, that was when I just had integers. Okay. Have a bit more than that now. HTMX makes web dev fun again. Yes, I have used it a bit. It's just not really, web dev in general. It's not really my thing. Oops. Fetch in. Nothing is better than Nginx. That's not a program language though, right? I guess I don't really know how that all works. I thought that was for, like, actually, I don't know what that was for. Yeah, I don't really understand WebDev. Comment. Not get removed. I am. Okay. Yeah, I just wanted to get rid of those files. So, yeah. So what I want to do though, I have these examples here. So I want to write a Python script that will run them, and then save the output of them to a text file, and then can run it again and compare them. And like if something breaks, then I'll know. So like test essentially. So actually, I'll probably rename this to test. Okay, there we go. Yeah, I don't know how I'm gonna do that now, but like probably will just be a Python script or whatever. Import it to Kano once Kano script once that is supported, right? Okay. Parts by gen. What is that? Yes, this is already a switch statement, so that's fine. Something I do have though in the front end, so in the Lex. Let's see, we have, yes, some of them could be a switch statement, but other ones cannot, so I'll probably do like that. Well, actually, that would probably be good as a switch statement, so I'll probably, yeah, I don't know that, I can make this a switch statement for these, and then like the default case can add the if statements, but I'll do that later. So I'll add a to-do for that, to refactor it. To refactor to switch statement. All caps, just because. Okay. So wait, no, something I was gonna do here. Hey, is this if else if a space u dot data? No, not config. Just I don't really want to break. And what is it? That I want to do here. This, right? No. If I do that, and then else, I just want to print an error if there is. I don't know if I have luck. Print an error if there's an unexpected token. Unexpected token, right? Expected token. Let's do that. That's not the right place. Script data over here. Locks. We don't have that, but we do have token not lock, so I can use that. Yeah, so we don't get that, but if I put something here that it's not expected, so I put like actually it's going to be interpreted as an identifier mode. So no, but like if I put like a star, well, no, we support that because that's multiplication. Hang on, what about like that? Yeah, unexpected. All right, that's what I want. Because then yeah, we can't put like garbage data in there, so that is good. Yeah, I wanted to do that, and we just ignore like any other space and things like that. Okay. Token consume. Yes, that was something I wanted to do, and there's another one. I think it's in the parse actually. I put like unexpected in the default case. Assert false unreachable. Yeah, that's not what I want to do. So, if you do this, like you can pretty easily encounter it. You just put like a plus here. Yeah, then in asserts, I don't really want that. I want to print error, right? Token data 0.1. Unexpected token that, and then token types data 0.type. Do that, and there we go. So that should be a better message. Unexpected token that. Did I put an extra new line? Didn't need that. And there we go. Okay, yeah, so that's better. Now it's not like an assert. You know it's not technically an assert anyway, but regardless. Yeah. Okay, so that's a bit better. And so so place with errors with print error in place. Okay. Yeah, okay. And alright, so that's better. That is better. Was there another place that I have assert? Like assert false reachable. So what is this? Yes, we should encounter this because we actually we enter this only if it already is one of those, so we know. So that is a proper assert. So this shouldn't really be an assert, should it? Well, yeah. Because if I am handling that, we shouldn't get to this point. Yeah. Okay, so I think that's fine. That's fine as well. And unexpected token, what is this? Yeah, I think you can still get this if we go kano.kano and we do something like let's see, x equals 5 plus 3 plus L, right? So that's being unexpected. Well, okay, that's not really. Plus that. That's unexpected. Hang on. So plus, yeah, we do this actually. Whoops, whoops. Plus, and then so like two operators. Then we get expected that. Oh shoot, that. Okay, yeah. I guess that is a proper service model because we do check. We check before, so that's fine. What is that? Segfault. Wait, what? Oh yeah, because this doesn't exist anymore. So we're trying to shoot. Yeah, we need to add. We need to check that. So that's trying to index into an integer. That's not exactly right. Yes, I do need to add check for that. That'll be in the type check. 8, is that right? Yeah. Okay. Cool, cool. Yeah, so I guess that's probably about it. A bit of a shorter stream. The next one's gonna be long because it's gonna be stuff with pointers and everything. So that should be fun. That should be fun, like memory and pointers. Okay, so I will commit all this. Did I wait, did I add assert? I think it was just to do with assert. So alright, there was actually none. So I'll push it. Okay. Gleam, yeah, so I'm gonna probably look into Gleam. I might try it out sometime because I think it could be fun. Okay. Alright, so all good. So yeah, thank you guys for watching, and I'll see you next time.